Okay, so welcome to analyzing data of our HC-SR04 ultrasonic sensor. So at this point, we have collected our data. Now we are going to analyze it. So before you see any of the highlighted boxes down here, you would have just had these 5 different trials that you did. So I've got our actual, which was our centimeters, our ruler measurement, and then I've got our Arduino values that were read off of the serial monitor as we measured, and then the difference. So the difference between the actual and the Arduino value. And how I did that really quickly with Excel was I just took the absolute value of the actual minus the Arduino value and came up with the difference. And then of course I just took my little crosshair and dragged that down, and it gave me the answers for each individual measurement. And then, so I did that for all 5 trials with the different material or the different item, and then I took the average of the differences. So basically for each one, what was the average amount that it differed, and that ended up being for our small box. Our first trial, for example, it was 0.352 centimeters was our average difference. And then I did the standard deviation of all of my differences. I think that data would be pretty significant when looking at how accurate the HC-SR04 is, how accurate of a tool that is. Just seeing how far the data is spread out from the actual measurement. So I took the standard deviation of that, which is 0.496, did that for each of the 5 trials. As you can see, they all do differ, some of them not as significantly as the other ones. For example, our oven mitt in trial 3, you can see it got some really wonky measurements. So the standard deviation, how much the data differed, was pretty wonky. In fact, we decided to just discard that trial when we look at our average of all the trials. Anyway, so then I also decided to do the standard error. We will do the standard error calculation as well, which is essentially just our standard deviation divided by the square root of the number of samples that we have, which in this case was 27 for 27 different measurements that we did. And so we did the standard error for all 5 of our trials. And so again, we see that there are some more significant standard errors than others, but for the most part, the standard error for our trials 1, 2, 4, 4 and 5, they were all pretty small. And so if you were going to graph this data, you would use this standard error as your error bars. So that's just, this is how far our actual data is, or the error of what it could be, that measurement. So then I decided to just compile all of those 5 trials minus trial 3, the oven mitt, because it really did give us some wonky data. The SR04 did not like that oven mitt. So we just excluded it as it was a major outlier, and there probably is a disclaimer out there somewhere that that module does not like textiles like cotton, so, but we're just going to go ahead and exclude it because usually you wouldn't be trying to censor things with a oven mitt. Maybe, I don't know, but I chose to exclude it. So what I did here was the same. I did the average difference for all 1, 2, 4, and 5 of our trials. I got the average Arduino value there between all 4 of those trials. And then I got that average difference as well. And that was 0.389 centimeters. My standard deviation, which, you just go in and use that Excel function, equals standard deviation, and come up here and drag down, and it gives you your standard deviation. Beautiful standard deviation there, super easy. And then I got my standard error for that as well. And the standard error for our average was the smallest one. It was the least standard error that we had of all 5 of those different charts that we did. Yeah, so that's pretty much it for the Excel tools that I used with that standard deviation and standard error. I think that students could make some really pretty graphs with that information. And then I also, just because I think that the whole science of the speed of sound is extremely interesting, and how this the SR04 is able to calculate that, I just decided to do it for myself. And so basically I took that formula that is given in the project description or introduction, that the speed of sound, how they calculated the distance was, they took the speed of sound, put that into centimeters, which was 0.034, and then they divided that by 2 because they've got to have, the traveling forward and then the bounce backwards. So you can see that formula up here. And then I wanted to figure out, well, I've got the actual measurement. I've got, if it is 2 centimeters away, what would the time traveled actually be? And so I figured that out here using this little algebraic function up here. So I basically took the actual measurement divided by that function that the Arduino uses to calculate and send back to the serial monitor. So I basically just did that here, and got these really cool time traveled measurements. And obviously you see that there's a distinct pattern. As the distance increases, so does the time traveled. And then I converted that to seconds. There's 1 million microseconds in 1 second, so basically just converted that. And that's also a super cool thing that I think that high schoolers would find really interesting, just to see how fast time actually does travel. But yeah, that is pretty much it for how we're going to analyze data here for our HC-SR04 ultrasonic